Hello, this is going to be the second example of drawing functions. So again, we've got a rational function. Why? Because we've got division between two polynomials, minus x squared and x squared minus 4. So the domain. Regarding the domain, rational functions have problems when the denominator is 0. That's why we will equal it to 0 and solve the equation with obtaining two values, 2 and minus 2. So the domain is going to be the rest. I mean, for all the values except from 2 and minus 2, f is defined. So from minus infinity to minus 2 to 2, 2 to plus infinity. Second step, asymptotes. We will start with the vertical ones, analyzing what happens really at these 2 points, I mean x equal minus 2 and 2. Do we really have vertical asymptotes there? So you define the limits approaching minus 2 and 2, and it seems these two limits both are plus minus infinity. If instead of plus minus infinity we had numbers here, we wouldn't have any vertical asymptote, but that's not the case. They're both plus minus infinity, so x equal minus 2 is the equation of one vertical asymptote, x equal 2 is the other equation of the second vertical asymptote. At this point, draw the x-axis, y-axis, and locate the vertical asymptotes. Horizontal asymptotes, limiting the plus infinity and the minus infinity. I started myself calculating the plus infinity one right side or right corner of the graph. So if we need to take the leading terms in the numerator and denominator, okay, and solution minus 1. So as this is a number and it's not infinity or minus infinity, we really have a horizontal asymptote on the right side, and y equals minus 1 is the equation of that horizontal asymptote. So let's draw it. And in the minus infinity is just the same. So y equals minus 1 is the equation of the horizontal asymptote on the left side. Third step, intersection points with the axis, x-axis and the y-axis. So y-axis. When x is 0, you need to replace 0 in the function, and we're obtaining y equals 0. So 0, 0 is the point we're obtaining here. X-axis, when y equals 0, so y equals 0 or f of x equals 0. So instead of y or f of x, I'm writing the 0 over here right now. And these kind of expressions are 0 when the numerator is 0, the one at the top. So 0 equals x squared, and it's quite obvious that x needs to be 0 in order x squared to be 0. So we're again obtaining the point 0, 0. Go back to your graph and locate it. And fourth step, increase and decrease interval on critical points. This is where we will need the derivative. So you need a division formula, and I calculated here, and this is the derivative once you simplify the numerator. So you equal it to 0 in order to see where the critical points are. So again, these kind of expressions are 0 when the numerator is 0. So 8 times x need to be 0. And that's when x is 0. So we've got one critical point, and that's at x equals 0. Draw the line, locate the vertical asymptotes. We had 2. One was at minus 2, the other one was at 2. I've got here the vertical asymptotes this way, and then locate also the critical point, which is at x equals 0. We've got here 4 intervals, 1, 2, 3, and 4. You need to choose 4 random values on them, and I chose myself -5, -1, 1, 4. You can choose any, any one you want. And we need to see which is the sign of the derivative at this points. So f prime of minus 1, I'm replacing minus 5 here at the top in the derivative, and that's negative, smaller than 0. It doesn't really matter the value, okay? The only thing that matters is being it positive or negative, and this one is negative, so arrow going down. At minus 1 is again negative, f prime of minus 1. Realize I'm writing here f prime and not f, and arrow going down. F of 1 is greater than 0, positive, so going up, and f prime of 4 is also positive, so arrow going up. Now at this point we're able to write the increase and decrease intervals. Just looking at the arrows, increase intervals, the ones that are going up from 0 to 2, from 2 to plus infinity. Decrease interval would be the ones that are going down, from minus infinity to minus 2 to 0. And there's a critical point where at x equals 0. So points are points, we need two coordinates, so x0, and replace the 0 in the function in order to calculate the second coordinate. We're not replacing here in the derivative, but in the function. So x is 0, y is 0. 0, 0 is a minimum, relative minimum. And let's draw. Now let's draw the graph of f. So from the left side, start drawing a line going down, and there's no any other way than doing it this way. Okay, then we've got a minimum at 0, 0, so we need to start from the upside going down, and that's the way. And right side of the graph would be that way. So this is our function of the second example.